In the attribute list, we saw so far 3 attributes. We have seen so far 3 attributes. All 3 are well-known, mandatory. Can you recall and tell me what are the 3 attributes that we have covered?
Is it well-known, mandatory, well-known, discretionary?
No. In well-known, mandatory, we have seen 3 attributes.
Oh, AS path, next hop, and origin.
Correct. AS path, next hop, and origin. Those 3 are well-known, mandatory. Alright, now this is local preference. It is well known, but may be present in the update, may not be also. See, this attribute actually is for those routers that runs BGP within an autonomous system. So, when there is an update between eBGP, you will not find this. Though it is well known, what is well known? Every vendor knows it. Every BGP appliance, every BGP devices know that there is an attribute called local preference. But between eBGP, local preference is not expected to be there in the updates because it's not necessary. Only between iBGP you need this. Local preference will be useful only between iBGPs. It will not be useful between eBGPs. Local preference is not useful between eBGPs. So, this won't be seen. That's why it is coming under discretionary, well-known discretionary attribute. Local preference is used to advertise to iBGP neighbors only. Now, what is the use of this local preference? This advises the iBGP routers how to leave the autonomous system if you want to reach some destination. For example, this local preference 200 that is set here will advise. I'm not only using the word advertise, I am also using the word will advise. Advertisement will go. In the advertisement, there is an advice given to every router that, see, to reach this 172.16.0.0, you may go like this, but I advise you, meaning I prefer you to come this way. Don't go via B. Don't go that way. I recommend you to come via this exit. Go via this exit. Leave via this exit. See? What is the use of this local preference? It tells the routers, it tells the iBGP neighbors how you should leave the autonomous system when you got multiple paths, which path you need to take to go out to reach the destination. So this Attribute is local preference. See, local. Meaning, it is sent only to IBGP neighbors. It is local within the AS. This is not necessary for another autonomous system. See, in your autonomous system, you decide to go this way. Why should you send this information to others? Not necessary. Why should this autonomous system need to know that you are going via A to reach this network? Not necessary. So this advertisement, this attribute, if you have set this attribute will be distributed to all the routers within the autonomous system, which we called as IBGP, but not to any router that is in another autonomous system. So it's only between IBGP, not with EBGP. So local preference attribute comes under well known but may be present. That's why it is discretionary. Now this local preference is a numerical value. The default is 100. Higher is preferred. For example, you see, this is one router. Let's say this is router K. Router K will be learning about 172.16 network from B, like this. It will also be learning the network from A. Now K has got two paths to take. But your policy says that you should leave the autonomous system via this direction, which this arrow mark shows, the black. That's how the packet should go. So what you can do, you can go to this router A and set high number. See, default is 100. You set anything bigger. See, in B they have set 150. So when you set 200, which is bigger than 150, all routers will know this because it is advertised to every router within the AS. It is sent to every router within the AS. So every router will know that going where A is the best path to reach 172.16.00. The preferred exit. But where do you configure this? You configure on A, but K will know it. You configure on any router, all other routers will know it because it is advertised to all the neighbors within the autonomous system. Please ask me questions. Is this clear what local preference attribute means?
Yes, sir.
Right.
So an exit path, right?
Yeah, it is. It helps every router inside the organization to decide the exit to reach some destination, to decide the exit from this autonomous system to reach some destinations.
And how do you configure it, sir?
Configuration we'll see later. Now, you need not to configure this on every router. You can configure only on A. Every router in the autonomous system. Here we don't have too many routers in the picture, but assume that you got 100 routers here. All 100 are running IBGP. It's BGP. Because they all belong to same autonomous system, all 100 router will know that preference on router A is 200, preference set on router B is 150. So let us all go via 200. So they all go via 200, means they all leave the autonomous system using A as the exit, not B. If the connection to A fails, then only it will switch to B.
Sir, in this case, even if we have given the router A local preference 200, if we require like one or two subnets should leave through B, can we configure that?
Very well, very well. See, our Girish question is this. We got 100 routes coming from outside. 50 routes I want to, for 50 destination I want to exit via A. For the remaining 50 I want to exit via B. Is this possible? Why not? It is possible. You can do that by using route map, or on high-end devices like ASR you can do it by using RPL, route policy language. But route policy language is not in this course. That is for service provider ASR devices. Here we'll be doing the same what you have asked for in the lab. We will be doing it using route map. So you can make use of both the ISPs, both the exit, and you can load share.
Okay, sir.
Welcome. Now next, let's go next. MED is an optional non-transitive. See, MED is optional, but in Cisco device, that MED, if it is not there, it won't use the update. See, optional and non-transitive, what does this mean? Optional, they are recognized by some implementations. Non-transitive means what? Discarded if not recognized. So even though MED is an optional one, Cisco demands it. Cisco says at least 0. The MED field should have at least 0. That field cannot be empty. In every update, MED will be there. 0 at least. If you give some number, then according to the meaning it will advertise. If you don't, it discards. Sorry, it will be 0. You cannot completely remove this attribute from any update. It will be always there even if you don't use it. You see? MED. MED stands for multi-exit discriminator. Because it is written metric, don't think it is metric. MED is not metric. MED is a metric used when you have multi-exit. Multi-exit not to the multi-homing but to dual homing. What it is? You see, router A has got multiple exit, or in another word, okay, let us do like that only. Router A has got multiple exit to reach this network. It can go this exit or it can go this exit. Now, this autonomous system owner who is providing you the service for you to reach this 172.20, he wants you to come this way. It's not you deciding how to leave. That is the previous one. Previous one, you are the owner of this autonomous system. You decide to leave like this. But here it is opposite. You, the owner of the down autonomous system, has got no influence with MED. MED who decides? B router is set to lower MED than C. Lower is always preferred. Lowest MED is most desirable, preferred. So B will be advertising with MED 150 this network. It will advertise this network with 150. C will advertise the same network with 200. A, on receiving this, decides to go this way because MED lowest is preferred. Whereas local preference default is 100, high value is preferred. Highest local preference is preferred. Don't forget. Local preference defines how to leave this autonomous system, whereas MED defines how a neighbor can approach me, how a neighbor can exit. I decide how my neighbor will exit. MED small is better, preferred. Multi-exit discriminator. See, A has got a multiple exit, and this is the discriminator which decides how A will exit. A receives update with two different number. It goes with the neighbor whose number is lower, and now it is only in between eBGP, whereas local preference is between iBGP. Local preference is within the autonomous system. MED is between the autonomous system. MED is decided. MED is configured by ISP. Decision is taken on the customer side. A is a customer. But A decision is based on what? The MED that is set by the provider, service provider. So the path with the lowest MED values are the most desirable. Lowest MED. MED is also called as what? Metric. But it's not a short form for MED is not a short form for metric. It is a short form for multi-exit discriminator. See, if you take EIGRP or any protocol, RIP, when we have two paths, path with the lower metric means less hop count is preferred, right? Metric is always lower is preferred. Small cost, small hop count, less hop count. That is what preferred. Same principle here. MED, metric. Metric should be always small. Small is preferred. Lowest MED value is most desirable. Whereas local preference is opposite. Highest local preference value is preferred. Local preference is within the IBGP. The default is 100. MED is between EBGPs and the default is 0. MED is used to advertise to EBGP neighbor how to exit their autonomous system to reach the networks owned by this autonomous system. This here means 65500. There here means 65000. MED attribute is an optional and non-transitive. Two attributes we have learned so far. Number one, local preference. Can someone give me one difference between local preference and MED? I'll give chance to everyone. So only 1 point.
Sir, may I? With local preference, it sticks within the autonomous system going outbound, and with the med attribute, it works with inbound traffic for an autonomous system.
This is between autonomous system. This is also going to influence the direction, but as you said, it is going to impact the inbound on the ISP side. For customer, it is an outbound, but we are setting this MED where on the ISP side. So for ISP, it is an inbound. Traffic should come inbound on router B, not on router C. So we have given lower number there. That's correct. Okay, any other difference? Next person.
So, MED has more preference when it is it's a lower value. Local preference is the opposite, which is higher value.
Right. Okay. Nice. Now next is, okay, one more point, another person. Right, when we configure MED, it is advertised to the eBGP neighbor, whereas when you configure local preference, it is advertised to all IBGP router. Even if you have 100 router, all 100 routers. Whereas when you configure MED, it will be only between eBGP. More input about this MED and distribution of MED attribute between neighbors we will see when we go live on the lab. But you see, this is what important thing. It is between eBGP, whereas this is between IBGP. Fine. Next is weight. Weight is an attribute which Cisco says it's very important. So in the attribute list, if you see, weight will be always on the top. Okay, now what is weight attribute? It's the same like local preference, but with one big difference. What? This will not be advertised to other routers in the autonomous system. See, the same like local preference in what way? It decides the exit. It is same like local preference in what way? Highest value is preferred. But the weight that you set on one router is going to help only that router to decide the exit, not to every router in the autonomous system. If you want every router in the autonomous system to decide an exit, then you need to use local preference. If you want only that router, other routers may go anyway, but that one particular router, you want that to exit via B, not to via C. Then you may set weight. See, weight is 100 with the neighbor B, 150 with the neighbor C. Higher is preferred, you see. That's the similarity with local preference. Weight and local preference is similar in this way. Highest weight is preferred. There, highest local preference is preferred. The default weight is 0. Instead of saying 0, I should say null. The default is null. You see? Weight. For local origin means the one which is originated on that router, advertised on that router, the next stop will be 000. For all those next stop with networks with the next stop 000, you will have 32768 weight dynamically set. We are not going to set. For the other networks, we can set. Right now it is 0, I can set to 10 or 20 or 200. But for those that are locally origined, means advertised on that router, Not learned from some router, advertised from this router. Highest weightage. So that it won't go anywhere else, it will use the local. Path with the highest weight values are preferred. Weight not sent to any BGP neighbor. It's local to the router only. It is not sent to any BGP neighbor. It includes IBGP, EBGP. See, you can configure this router anywhere. You can configure on one router which is inside the autonomous system, which is in the border. It can be anywhere. Wherever you put this command wait and show a path, this is the path over weightage. Regardless of EBGP or IBGP, it will work. Again, it is local to the router. So this need not to be advertised to anyone. Alright, so any question on the three attributes that we have learned? Weight, local preference, MED. Weight will not come under well-known, mandatory or well-known discretionary or optional transitive or non-transitive. Why it won't come under any of those things? Because this is Cisco only router, only attribute. And it is decided only on that router. It is used to decide on local router. So, first of all, it is not a well-known because it is Cisco only. There is no concept of may be present, may not be present because it is not useful for anyone else. It's only for local. So, it's not any of this. It is not any of this category. Yep. So we have learned weight, local preference, MED. These three we have to do in a lab and see. Please ask me coding. So weight is configured on your router. Impact is on your router, your autonomous system. MED is configured on your neighbor's autonomous system, but the impact is on your autonomous system, your router. Fine. Now let us see one example for weight. See, I have router 1. Router 1 right now, to reach 55 network, it should be going via router 4. See, show IP, BGP. Oh, wait some time, it will come. The neighbor has come, but routes are not learned so far. Show IP, BGP summary. We have a neighbor. Neighbor is up. Let's go to router 5 and check whether this is configured fully. Yeah, looks like it is also having neighbor. Show IP BGP. Oh, this is not advertising. Why? Show RAN section BGP. Oh no, there is no advertisement. Let's advertise. Router BGP 5000. Network 55.55.55.55. Mask 255.255.255.255. Done. You see, I have advertised this 55 network on router 5. Now let me go to router 1 and check. Listen carefully. Router 1 is learning one prefix, one network. What is that one network? 55, 55, 55, 55. From router 2. Also from router 4. Locate it on the topology, what I am saying. Router 1 is learning 55, 55, 55, 55 from two different autonomous systems. One is router 2 autonomous system 2000, another one router 4 autonomous system 4000. And what is that one network? Show IP BGP. This is that one network. It has decided to go via router 4, which is autonomous system 4000. You know why? Why? Less AS jumps, lesser AS path. Only two AS, two hop. So if you have this greater than symbol, it means that's the best among these two. This is not a bad one, it's a valid one. In case if this fails, this will be used, but currently it cannot be used because of the tie break. AS hops is a tie break. Lesser the AS hop, better is the route. So, router 1 decided to go via router 4. You can check that in the routing table. Show IP route BGP. You see? It is going via router 4. Goes via router 4. I don't like this. Assume. I don't like this. I want it to be sent via router 2. I want this greater than symbol for this. Even though it's a long path, I want that path. So what I can do, I'm going to set weight. The default is 0, 0. There is a tie. But if I will set more weightage to this neighbor, whatever that neighbor gives will be preferred. How to do that? See, like this. Router BGP 1000. Neighbor, this neighbor, weight. See how easy it is? 160, something like that. Default is what? 0. I have given 160 now. So it compares the weight. 160 is bigger than 0. So it will go via router 2. Let's go and check now. Show IP BGP. Look at this. Still not changed. It will take some time. So what I'm going to do is to make the impact happen immediately. I say clear IP BGP star soft. Use the word soft. If you don't use the word soft, it will be disruptive. I'll teach these things later. Now you see it is switched to the router 2 path because we have set 160. See, immediately after setting, I showed you it was not updated. But when I clear and make BGP to restart again from the beginning, it came. And now even though it's a long route, it's a preferred route now. Check the routing table. Earlier it was going via router 4, but now it goes via router 2. Let me show you what we saw earlier. Earlier it was going via router 4's address, router 4, but now it goes via router 2. Yep. So I just showed you only one attribute out of 4 we learned. 4 or 3. How many we learned? Local preference we learned. Local preference is well known but discretionary. MED we learned. Optional, non-transitive. Is it optional, non-transitive? Next, wait will not come under any of that category. It's Cisco only router attribute, which I showed you just now. I want you to do these things. The wait lab, do wait lab, and then recall all those things that I have taught you today before you come to our next class. In the next class, I have just 2 slides. I would have finished today itself, but that's not my aim. Finishing is not our aim. We need to understand and go. So, just 2 page, 1, 2 page summary comes. But I do not want to finish that fast like that. We have to learn a lot in this. And we need a big topology also. This topology is not enough for me to demonstrate local preference and MED. That's why I'm postponing those things to tomorrow. So tomorrow we will be doing lab exercises. Remind me, we have to do lab on local preference and MED. But before that, I have to finish for you this page and this page. Remember, we have to learn 2 more pages in this chapter, and then we'll go to the lab. Lab topology will be little bigger than what we have right now. I'll do some alteration. Thanks for joining today. Have a wonderful day. See you tomorrow. Take care.
First, you